Good morning everyone. So today in this video we are going to solve few more examples on discrete data. So today I'm just going to show some different way of doing that. So if you are given some discrete data, that is xi comma yi, where this I runs from 1 to up to so on m, that means you are given some m points and you have to fit this data into a linear equation y equals to a naught plus a1 x. Then what you need to do is there is direct and formula for it, that means m into a naught plus a1 summation xi I goes from 1 to m equals to summation yi I goes from 1 to m, and a naught summation I goes from 1 to m xi plus a1 summation I goes from 1 to m xi square, which is equal to summation I goes from 1 to m xi into yi. So with the help of these two normal equations, what we get is value of a1 equals to m into summation of I goes from 1 to m xi yi minus summation I goes from 1 to m xi into summation I goes from 1 to m yi upon m into summation I goes from 1 to m xi square minus summation I goes from 1 to m xi whole square. Okay, and value of a naught is given by y bar, that is minus a1 x bar. So this y bar is nothing but the mean of values of yi, and x bar is the mean of values of xi bar. xi. So now we will see one example based on this formula. So find the best values of a naught and a1 if the straight line y equals to a naught plus a1 x is fitted to the data xi yi, which is given as 1, 0.6, 2, 2.4, 3, 3.5, 4, 4.8 and 5, 5.7. Okay, so now we have to form a table. So for that, let xi all the values of x, so 1, 2, 3, 4 and 5, yi is 0.6, 2.4, 3.5, 4.8 and 5.7. Now xi square is nothing but, you have to square this, so 1, 4, 9, 16, 25, xi yi, whatever the values we need, so xi yi, so it is given by 0.6, 4.8, 10.5, 19.2, 28.5. Okay, next one is we have to find yi minus y bar square. yi minus y bar square is needed to find the correlation coefficient. So we'll consider this. So yi minus y bar square equals to 7.84, 1.00, 0.01 1.96, 5.29, and the other term which we need is yi minus a0 minus a1 xi square. So first of all we need to find a0 and a1 values, so we will fill this part later. So with the help of this, a1 equals to, now we know that a1 equals to m. M is total number of points, so 5 points into summation of, so we need to find summation of all this. So summation of xi is 15, summation of yi is 17, summation of xi square is 55, summation of xi yi is 63.6, and summation of this is 16.10. Okay, so now a1 is given by m into summation of xi yi, which is equal to 63.6 minus summation xi yi, so it is minus 15 into 17 upon summation m into, so m is 5 into summation of xi square, summation of xi square is 15 minus summation of xi square, so a summation of xi is 15, so 15 square is 225. So after solving this, we will get ai equals to 1.26. Okay, so similarly a0 is given by y bar minus a1x. So now this y bar is nothing but the average of yi, which is average of y bar is 55 minus a1 we got 1.26 into, so here y bar is the average of yi, so it is 3.4 minus even we got here 1.26 into, what is the value of x bar? X bar is average of xi, so it is 3. So solving this, we get a0 equals to minus 0.38. Okay, so the required equation what we need is, so y equals to a0, it is minus 0.38 plus a1, it is 1.26 into x. So this is your required linear equation. So now we will calculate the value of yi minus a0 minus a1 xi square. So the first one is 0.0784. Similarly, the second one is 0.0676. Third one is 0.01, 0.0196 and 0.0484. Okay, and the summation is, total summation of all the numbers is 0.2240. Okay, so we got the value of this. Now we need to find the correlation coefficient. Now correlation coefficient is given by square root of whatever the yi minus y bar whole square, whatever the summation is, that is 16.10 minus the summation of this entire yi minus a0 minus a1 xi square, which we have got as 0.2240 upon 16.10, that is again yi minus y bar whole square. So after calculating all this, you'll get 0.9930. Okay, so this is our correlation coefficient. So now we will move on to our next sum, that is certain experimental values of x and y are given below. So they are as follows. So 0, -1, that's our first pair. Then 2, 5, 5, 12, 7, 20. Okay. So now we have to fit this data into a line which is given by, so if the straight line is y bar equals to a0 plus a1x is fitted to the above data. We have to find the values of, that is the approximate values of a0 and a1. So to find this, we will again have a table. So this one is simple one, that is x, y. So what are the values of x? That is x coordinate 0, 2, 5, 7. Similarly -1, 5, 12, 20. So these are your x and y. So you need to find x square and xy. So x square is 0, this is 0. Again 4, 25, 49. Then this will be 10, 60 and 140. So again summation of all this is given by, so summation of this 14, 36, 78 and 210. Okay, so these are the summation. Now we need to find the normal equations. To find the normal equations are given as, so now we need to have the formula. So we know the formula, which is given as m into a0 plus a1 summation xi, which is equal to summation of yi. So this is the first one, and our second one is a0 into summation xi plus a1 summation ironing from 1 to m xi square equals to summation xi yi. So we are going to use these two equations to form a normal equation. So we'll get, so m is total number of points, so there are 4 points. So 4 into a0 plus a1 into summation of xi. So summation of xi is a 14. So into 14 equals to summation of yi, which is 36. So we got a first equation as 4a0 plus 14a1 equals to 36. Okay, so this is the first normal equation, and now to find the second one. So second equation is given by a0 into summation of xi is 14 plus a1 into summation of xi square, so which is equal to 78, and this entire thing is equal to summation of xi yi, that is 210. So we got the second one. So 14 a0 plus 78 a1 equals to 210. So this is the second normal equation. So we need to solve this both the normal equations, and you have to find a0 and a1. So you can use any of your method. So just you have to solve it. I'll directly write down the answer, that is you'll get a0 equals to minus 1.1381 and a1 equals to 2.8966. Okay, so now the best approximation equation is the best straight line fit is given by, so y, which is equal to now a naught. So value of a naught is minus 1.1381 plus x into 2.8966. So this is our approximate function equation, sorry. So in all the previous sums, what we have said is, if we have discrete, then it is in two tuple. Okay, so x and y coordinates are given. So what if three coordinates will be given? For example, x, y, z. So this will be the data. It might be x1 comma y1 comma z1 and x2 comma y2 comma z2 up to so on, xm comma ym comma zm. So if discrete data is given in the form of three tuple, then you have another formula. So I'll just note down the formula. There is no need to find the derivation for it. So the formula for such kind of data is m is total number, again total number of points, so m into a naught plus a1 into summation of xi plus a2 into summation of yi equals to summation of zi. So a0 summation xi plus a1 summation xi square plus a2 summation xi yi equals to summation of zi xi. And the third one is a0 summation yi plus a1 summation yi xi plus a2 summation of yi square equals to summation of zi yi. Okay, so these three are the normal equations, and with the help of this you need to find values of a0, a1 and a2. So we'll see one example based on this so that it's easy for you to understand. So our next example is, find the values of a0, a1 and a2 so that the function z, which is equal to a0 plus a1x plus a2y, is fitted to the data x, y, z as given below. Okay, so this is the discrete data. So we'll again plot a table. So the following table is as follows: x, y, z. So then 0, yeah, we'll write down the x coordinate first. So 0, 2, 3, 4 and 6. Y coordinate 0, 1, 3, 2, 8 and z is 2, 4, 3, 16, 8. Okay, so this are first of all the xyz values of that. Then x square, which is equal to 0, 1, 4, 16, 36. We need again y square. So y square is 0, 1, 9, then 4 and then 64. Okay, values of xy. So you need to multiply this. So 0, 1, 6, 8, 48. Similarly zx, which is equal to 0, 4, 6, 64 and 48. Now last one is yz. So yz multiplying 0, 4, 9, 32 and 64. Okay, so these are the values of all the things which we need. Now again we'll find summation of all this. So summation of x will be 13, summation of y will be 14, then 33, 57, 63, no 78, sorry 78, xy will be 63, zy will be 122 and yz will be 0.09. Okay, so we got all this value. Then we'll substitute this in our equation. So first equation was m into a0 plus a1 summation xi plus a2 summation yi equals to summation zi. Okay, so this was our first. So m is total number of points, so 1 2 3 4 5, so 5. So 5 a0 plus summation of xi is 13, so 13 a1 plus summation of yi is 14, so 14 a2 equals to summation of zi, which is equal to 33. So this is the first one. Now similarly we are going to find out the second normal equation. So second normal equation is given by a0 summation xi plus a1 summation xi square plus a2 summation xi yi, which is equal to summation zi xi. Okay, so again summation xi is given by 13 a0 plus summation of xi square, which is equal to 57 a1 plus summation xi yi, which is equal to 63 a2, which is equal to 122. Similarly the third one, a0 summation yi plus a1 summation yi xi plus a2 summation yi square, which is equal to summation zi yi. Okay, so again substituting its values, 14 a0 plus yi xi, so 63 a1 plus 78 a2 equals to 109. So you got this three equations. You need to solve this using any of the methods you follow, you wish. So after solving it, you'll get the values of a1 as 5, a2 as -3 and a0 as 2. Okay, so these are the values of a0, a1 and a2. So this is based on discrete data where the data is given in the form of 3 tuple x, y, z. Okay, next is curve fitting by polynomials. So for this, if you have a polynomial y which is equal to a0 plus a1x plus a2x square plus up to so on plus an x raised to n. So if this is polynomial, then normal equations are given as m, that is total number of points, into a0 plus a1 into summation of xi plus a2 into summation of xi square plus up to so on plus summation an into summation xi raised to n, which is equal to summation yi. So a0 summation of xi plus a1 summation of xi square plus up to so on plus an summation xi raised to n plus 1, which is equal to summation xi yi. Continuing in this manner, the last one is a0 summation xi raised to n plus a1 summation xi raised to n plus 1 plus up to so on plus an summation xi raised to 2n, which is equal to summation xi raised to n yi. Okay, so what we need to find is total number of points, then summation xi square up to so on xi raised to 2n. So if for example value of n equals to 2, then we have to find up till summation of xi raised to 4. Similarly, we have to find summation yi, summation xi yi up to so on summation xi raised to n yi. We'll see one example so that it becomes easy for us. So let's see one example. So fit a polynomial of the second degree to the data points x comma y given by 0, 1, 1, 6 and 2, 17. Okay, now we have to find a polynomial of degree 2. That means we have value of n equals to 2. So we need to find summation of xi, summation of xi square, summation of xi cube and summation of xi raised to 4, because 2 into 2, that is 2n equals to 4, fn equals to 2. So you have to find this. Then we need to find summation of yi, summation of xi yi, summation of xi square yi. Okay, so we need to find all these terms. So x, y, x square, x cube, x raised to 4, y, xy, x square y. So we need to plot the table. So values of x are 0, 1, 2. There are only 3 values. Y is 1, 6, 7. X square 0, 1, 4. X cube is 0, 1, 8. X raised to 4, 0, 1, 16. Again, okay, so sorry, y won't be there. So directly xy, so 0, 6, 34. X square y will be 0, 6, 68. Okay, so again we need to find the summation of all this. The summation will be 3, 24, 5, 9, 17, 40 and 74. Okay, so these are all the summations. So again we will substitute the values of whatever we got. So m, that is 3 into a naught plus summation of xi, which is equal to 3, so 3a1 plus summation of xi square, which is equal to 5a2, which is equal to 24. Okay, so that's our first normal equation. Second will be again 3a0 plus 5a1 plus 9a2, which is equal to 40. Then 5a0 plus 9a1 plus 17a2, which is equal to 74. So these are the normal equation which we need to find. Now again solving this, you can have the values a0, which is equal to 1, a1 equals to 2 and a2 equals to 3. Now we need to find another example. So second, fit a second degree parabola y, which is equal to a0 plus a1x plus a2x square, to the data xi, yi, which is 1, 0.63, then 3, 2.05, 4, 0.08, and 6, 10.78. So this is the data. Now we will plot the table again. So again x, y, we need to find second degree again like this. Similarly, we have to go up this summation of xi raised to 4 and xi square yi. So xy, x square, x cube, x raised to 4, xy, and x square y. Again 1, 3, 4, 6, which summation is 14. Similarly y 0.63, 2.05, 4.08, and 10.78, which is equal to 17.54. Again 1, 9, 16, 36. Now the summation is 62. X cube. So 1, 27, 64, 216. Now the addition 308. X raised to 4, 181, 256, 1296. Okay, the addition 0.63, 6.15, 16.32, 64.68. So the addition is 87.78. Similarly 0.63, 18.45, 65.28, 388.08. Addition is 472.44. Okay, so these are the summation. Now we need to find the normal equation of this. So okay, use the formula. So 4a0 plus 14a1 plus 62a2, which is equal to 17.54. 14a0 plus 62a1 plus 308a2, which is equal to 87.78. 62a0 plus 308a1 plus 1634a2, which is equal to 472.44. So we got all the three normal equations. Now solving this, we'll get values as 1.24, a1 which is equal to minus 1.05, and a2 equals to 0.44. So these are the values of a0, a1, a2. Thank you.